Welcome, my name is Chloe and this video is to introduce you a software GeoModeler. GeoModeler is a 3D geological modeling and geophysical inversion package. So what GeoModeler does? The software will quickly produce 3D model from sparse geological observations, and the model will be easily updated by integrating more detailed data. The model can also be compared with geophysical observation by forward modeling and modified if necessary by stochastic inversion. This part is developed in another video available called GeoModeler Geophysics Introduction. In this video, to show you the basis on how to build a geological model with GeoModeler 2012, I will go through the key steps of the building of a project called Brookman Syncline realized for Rio Tinto in Western Australia. So, when you open GeoModeler, this is the first interface of the software. I would like to show you first how to create a project from the very beginning. So, if you go on the project in the main menu, you can either browse an old project, so you can see here the list of the old opened project, or create a new one. When you click on New, this window pop-ups. In this window, you're gonna decide the name of your project, you can put the author and few description of your project. The most important is to set the projection of your geological model. This projection will have to be exactly the same for every geological data you're gonna bring to build your model. The next step is to define the limit of your geological model, the extent of the box you're gonna build your 3D geological model into. We can put, for example, 2 km on Y direction and 1 km on X direction. When it's done, you just click on OK. You can see over here that GeoModeler built an empty box with the limit you just entered. But before start any modeling, you need to either download the DTM if it's available, or define the topography surface as an horizontal surface. So if the DTM is available, you can download with this window. Otherwise, you can design and decide that your topography surface will be flat and at, for example, sea level. If I click on OK, on the left hand side you've got your surface topography in yellow, and you can see it as well in your right hand side in your 3D box. So that was to show you how to start a model from the beginning. Now I'm gonna open the Brookman Syncline project that we already started to build. You can see that we have already few points digitized. So, and we had in this model the DTM available. So this is a grid of the DTM available. And if I put a bit of vertical exaggeration on the 3D viewer, you can start to feel the shape of the DTM digital terrain model at the edge of your 3D box over here and here. So if I turn on the grid, you can see that for this model we already started to build some formations. So you've got the list of the formations entered in the model. So how to do that? You go on Geology, Formation Create. You put a name and assign a color to the formation. When it's done, you have to define your stratigraphic pile. Here you visualize your stratigraphic pile. And under Geology, you can design over here the relationship between all your formations and design your stratigraphic pile. So you can see on the surface topography, we have already a few points digitized. Those points have been digitized with a geological map we had available in our hand. So we brought this geological map like I'm doing right now. Any image, JPEG, is possible to bring into GeoModeler. You need 3 points georeferenced that you can enter the coordinate in this window. When it's done, you just click on OK, and GeoModeler will import this image into your surface topography at the right location. So if I turn on and turn off the map, you can see that the points already traced are related to this geological map. So you can see we have two types of points. We have contact data and orientation data for each formation of a model. And that's all what we need to compute a 3D geological model. So if I click here, this window will list all the geological information we have currently in her model, and if I click on OK, GeoModeler will compute the geological model. So it's done, it's finished. It was really quick. Now we need to plot this geological model computed, for example in her 2D view. So you can see so far we've got only few formations. You can recognize the syncline shape. And if I put the map on top of my model computed, you can recognize the syncline below the quaternary cover. So this map is really complex, and a model will have to be improved to fit better the reality of the field. But first, let's compute 3D shape of her first geological model. And you can see we can recognize the simple model we have so far. So the principle of GeoModeler is to incorporate more and more geological features as the data are coming. So if you look at the geological map, you can see that we have a fault network. And the next step for us is to digitize those faults. So we've got two types of faults in this map. We've got infinite fault that go through all the area of a model. And if I zoom here, the finite fault that stops before the end of a model. So what I'm going to do is open another step of her project over here below, and that's it. You can see, you can recognize the Bookman project if I plot the geological map. So what we've done, we have created two type of faults, A1, A2 and B1, B2. And we have started to digitize the fault A1. The fault A1 in red are infinite faults. They cross all over the project. But the faults B2 are finite faults here. And you can see the fault, this one, stopped before the end of the project. So to digitize the fault B2, I just take my pen over here. I draw a few points along the fault. And now I have to attribute those points to my fault. So I click over here, select B2, and then I can associate to those points a deep angle, which I'm going to consider this fault as a vertical fault, so 90 degrees. When it's done, I can click on Create and Close. So now my points have been attributed to my B2 faults. So if I turn off my geological map over here, yep, you can see they became orange. So the next step when you create a fault is to define the link between your fault and the geology formation. So if the geological formation is going to be affected by your fault, you need to tick in this window the series of your geological formations. If it's ticked, the formation will be affected by the fault. As the orange B2 fault is a finite fault, we need to tell to GeoModeler that this fault isn't infinite. So you can select over here finite, and then you have to attribute an horizontal radius, a vertical radius, and an influence radius in kilometers. When it's done, you can click on OK, and all the parameters of your fault are done. We can now compute a model including a fault. So you can see in my compute model window, I've got my series of faults over here. I select everything and click on OK, and my new model has been computed. I can plot only my fault in my 3D shape, and you can see the starting of my fault network. The red infinite fault and the orange finite fault. I can also plot the rest of my geological model and my formation as surfaces, so you can see my fold going through my syncline shape. I can put a bit of vertical exaggeration. That's it. Well, so we started to digitize few folds, but if I go back to my geological map, you can see that there is a lot of more on the east part of the map, and there is a few other formations that we need to digitize as well. So if I open a step further of the project of the Bookman syncline and plot my geological map again on top over here in my surface topography. So on the east part of the geological map, we had digitized a group of folds in green over here, and a network started to be a bit more accomplished. When you look at the geological map, you can see that you've got still a lot of formation that we haven't digitized yet. And I would like to put your attention on this tiny area, the PLTUK formation. This formation is actually on top of the folded series. Unfortunately, in the geological map, it's covered by quaternary sediment. So we won't be able to use this geological map to digitize the contact between this formation and the rest of the series. Fortunately for this project, we had drill hole information. So the first step is to create the formation and add the formation to the stratigraphic pile. So we put the formation on top of the folded series over here, and we commit when it's done and close. We can check a stratigraphic pile over here, and you can see the PLTUK is on top of the series. So now we can import a drill holes data to build this formation. So you need to import 3 files: the COLA, which is the location of the head of your drill hole, the survey, and the geology. And if you follow the step of the import tool, you can easily bring any drill holes data into your GeoModeler model. So you click on finish, and when it's done you get a report, and you can see in your Explorer menu the 3 drill holes that you just imported. So you can edit the drill holes, and you can see the new formation is inside your drill holes. So GeoModeler is going to use those 3 drill holes to build the geological model and build this formation. So we can now compute a model with, you can see, the drill holes. So that's it, a model has been computed. So if I plot and project my drill holes under this cross section, which is over here, go back to the cross section, I can project my drill holes in this section. That's it. They're quite shallow. That's 2 shallow drill holes we've got in this section. I can plot the drill holes in 3D. So if I put a bit of vertical exaggeration to see them and make them a bit bigger, you can see your 3 drill holes that GeoModeler will use to build your PLTUK formation. So now I can plot the model I just computed in my cross section. And you can see that the new model has this new formation, and the formation is following exactly the drill holes limit of the PLTUK formation. So if I plot in my topography surface, that's it. We've got this new formation that wasn't there before, and it has only been created from drill holes information, nothing else. So if you look at the model, you can see that we have a lot of more formations to create at the edge of the folding. So if I open a new project, a step further of the project, over here, this is the final step of the project. Obviously a project is never finished, you can always bring data as they come to you, but this one is when we stopped to work on this project. You can see that we created cross-section, a lot of cross-section. We also put more formations, all the formation we had in a stratigraphic file originally. And we imported as well a lot of map. So you can basically bring any image or map that will help you to digitize the limit of your formations. So if I had the others and keep only the geological map here. So that's the final model, I would say. And you can see that in one of the cross-section we also brought an image of a cross-section that also helped us to put some contact data and build a geological model. So we have also a lot of more drill holes with, if I edit one of them, more geological formation. And if I show them in 3D with vertical exaggeration, this is a group of drill holes that has been used to create the geological model. So we brought everything we had, as well as contact and orientation data that we digitize in the surface topography. So we've got the fault network, which is now completed, and we've got all this contact and orientation data. Everything served us to compute a nice geological model. So if I compute my model and then I plot in 3D with a fine resolution of it, so I push forward the quality of the resolution to high and click on OK, I can build a nice geological model result. So you've got a time scale over here that will tell you when the building of your shape is finished. And if you wait long enough, depending on the capacity of your machine, you can end up with this type of 3D model. So you can play with in 3D, so you can obviously put some vertical exaggeration. And you recognize the folding in 3D. You can, as well as turn it around, you can make some formation transparent. So for example, let's put this one a bit transparent so you can see the fault going through the formation. So it can take a bit of time because that's a high quality model. But when it's done, you can turn it around and you see the fault network going through this formation and affect these formations. You can also hide other formation as you wish, and basically that will help you to think about your geological model. We interpreted it in 3D, and if you're not happy with the result you've got in 3D, you still can change some contact and orientation data, modify the information you've got in your topography surface to make it more realistic to what you see on the field. So thank you for your attention, and I hope this video will help you to start with GeoModeler 2012 and create your first 3D geological model.